Hello, this is a TheFlightChannel production. Please, if you liked the video, hit the like button down below and subscribe to see more. Thank you. So, today's question. Why can't an airplane just fly into space? Why do we need rockets? Airplanes, especially commercial jets, fly really high in the sky. So high in fact that the only thing visible to passengers are often fluffy clouds. However, have you ever wondered how high commercial airplanes can fly? What if they continue to ascend into the sky? Could they leave Earth and reach the blackness of space? If you sit down and seriously think about this idea for a moment, your practical self will almost instantly tell you that this must be impossible. If it weren't, then people more actively involved in sending rockets into space must have obviously thought about the possibility of sending airplanes into space. The fact that we don't see commercial jets shooting off into space seals the fate of this hypothesis. To expand on a little further, you should know that commercial jets usually fly at an altitude of 28,000 to 35,000 feet. However, that's not the highest they can go. They can go a little higher, but most large passenger airplanes are not designed to fly much higher than about 12 kilometers or 7.5 miles. The air is too thin above that altitude to hold the planes up. One exception to this was the Concorde, a supersonic commercial jet whose maximum cruising altitude was 60,000 feet. Some kinds of plane can fly much higher, and one special NASA plane named Helios flew to about 30 kilometers or 19 miles, which is far higher than any other plane has traveled. However, it was manufactured by NASA, so it's hard to call it a normal commercial jet. If you continue going upwards in the sky, when do you enter space? Well, the shortest distance to enter space is 100 kilometers or 62 miles. After you've traversed that far, only then can you expect to cross Earth boundaries and enter suborbital space. Of course, provided everything works as planned. As discussed before, airplanes cannot even think of going that high. So, to answer the question in short, airplanes cannot go into space. Now that we have the yes or no part of the question covered, let's move on to the part of why. This limitation on airplanes is the result of two main reasons: the availability of fuel and the way the airplanes are designed. Airplanes are able to fly only because their large wings generate enough lift to keep them airborne. This lift in airplanes is generated by the way the air flows above and below the large wings, thus keeping the airplane in flight against the gravity of Earth. Essentially, it's the air that makes an airplane fly. The engines just provide enough power to the airplane to keep it going against the aerodynamic drag. Most of the time, air may not seem like a very real substance like water, wood or metal. But when the wind blows so hard it nearly knocks you down, air seems very real indeed. If we think about it, we can begin to understand how essential it is to how airplanes work. Given their critical dependence on air, the way airplanes operate in the sky is hugely influenced by the quality of air. You see, as altitude increases, the density of air decreases, slowly at first but rapidly after a certain A. In short, air becomes increasingly thinner with increasing altitude until the point where there is no air at all. Flying machines like airplanes need lift to stay airborne, which is generated by air. If there's no air to begin with, they obviously cannot fly. Another reason for which airplanes cannot fly into space is speed. Do you remember the Concorde that we mentioned before? Well, it flew at 60,000 feet or 18,300 meters, and where the air density is just 7% of that at the sea level. To achieve this height, it had to travel at Mach 2, twice the speed of sound or 1,350 miles. Planes have to fly faster to create more lift until eventually they reach an altitude where the engines cease to function correctly because of the lack of oxygen or the air is too thin to create enough lift. The highest flying jet plane was the Lockheed SR-71 Blackbird, a long-range aircraft that was capable of taking off and landing unassisted on conventional runways. It was operated by the United States Air Force from 1964 to 1998, and a total of 32 aircraft were built, where 12 of them were lost in accidents. However, the Blackbird flew at 85,135 feet, where the air density is just 2% of that at the sea level, and with a speed record of 2,193 miles per hour or 3,529 kilometers per hour. The pilots of this plane had to wear a full pressure suit with its own oxygen supply in case of an emergency ejection. Now, while you would think that the SR-71 was fast, to get into space, you need to reach what is known as escape velocity. You reach this velocity when you are traveling faster than gravity is pulling you back to Earth, and that speed is 25,020 miles per hour or 40,270 kilometers per hour, much more of the maximum speed that the most common commercial airplanes can reach. To get a spacecraft to even the lowest Earth orbit requires a rocket. So, how is a rocket different from an airplane? Rockets do not depend on air, even for burning their fuel. Rockets take advantage of some basic laws of nature that were discovered by the brilliant scientist Isaac Newton late in the 17th century. One of these, called Newton's third law, say that for every action there is an equal and opposite reaction. This explains what is going on when you blow up a balloon, then let it go without trying a knot. The air rushed out of the mouth of a balloon, and that pushed the balloon in the opposite direction. This law also tells us that to build a powerful rocket, we need to shoot out a lot of high-speed material opposite the direction we want the rocket to go. That is exactly what a rocket engine is designed to do. Most rockets use high-speed exhaust gases from burning rockets' fuel to propel themselves up and away from Earth's surface to the vacuum of space. Unlike planes, they do not need air to lift them up. Like everything else that burns, rocket fuel cannot burn without oxygen. Because it operates where the air is too thin to provide enough oxygen, a rocket carries its own oxygen in tanks and mixes it with the fuel just before it's burned. Rockets not only make space exploration possible, but they also enable us to explore our own planet in a way we could never do even from an airplane. But what about the future? Will we ever get planes that can take off from an aircraft standard runway and fly into space and then return back? Well, a design which looks promising is a Scalon. Scalon is a design for a single-stage to orbit spaceplane by the British company Reaction Engine Limited, using Sabre, a combined cycle air-breathing rocket propulsion system potentially reusable for 200 flights. In paper studies, the cost per kilogram of payload carried to low Earth orbit in this way is hoped to be reduced from the current 1,108 pounds per kilogram, including research and development, to around 650 pounds per kilogram, with costs expected to fall much more. In 2004, the developer estimated the total lifetime cost of the program to be around $12 billion. The vehicle design is for a hydrogen-fueled aircraft that would take off from a purpose-built runway and accelerate to Mach 5.4 at 26 kilometers, 16 miles or 85,000 feet altitude, using the atmosphere's oxygen before switching the engine to use the internal liquid oxygen supply to take it into orbit. The vehicle will be unpiloted but also be certified to carry passengers. All payloads could be carried in a standardized container compartment. The relatively light vehicle would then re-enter the atmosphere and land on Earth. Unmanned test flights of the Scalon could be happening by 2025 if everything goes well. There are several reasons why Scalon remain uncompetitive when compared with rockets, for example the Falcon. Scalon costs about 30 times more than a Falcon 9 and 20 times more than a Falcon Heavy. Falcon 9 and Falcon Heavy are two rockets designed by the US-based SpaceX company. Using an exotic and relatively expensive combination of jet and rocket propellant, it costs about 6 times more to refuel Scalon than a Falcon 9 and twice as much as a Falcon Heavy. It also needs to take off from and land on a 5 kilometers long runway, while the Falcon 9 can launch from an area about the size of an oversized helipad. On the other hand, SpaceX, a company valued at £8 billion with around 4,000 staff and currently turning a profit, is perhaps no more than a few years away from a fully operational first-stage reusable Falcon rocket program. Anyways, only time will tell us what will happen. So this was why container plane just fly into space. Thank you so much for watching. If you want to support this channel, then please take a look at my new shop. You can find the link here and in the description. In the shop, you can find nice t-shirts, sweatshirts, mugs, stickers, everything related to aviation and traveling. I will get a very small part of the revenues generated and they will entirely support the channel. Once you decide your design, you can click on it and you can customize it. You can change the color, and you can choose if you want a t-shirt or a sweatshirt. Other than that, you can support the channel by liking this video, but most of all, subscribe if you want to see more videos like this. Thank you.